The engine and gearbox is ready to go back into the Duetto project. However, before I can do that, I need to address the steering. I didn't drive this car, apart from moving it into the workshop when it arrived, so I can't really comment, but the owner told me that the steering was rough and heavy, and it's quite clear the steering box itself leaks very badly. So I'm going to get this box right, and then the engine can go back in for good. I've never rebuilt one of these boxes before, and they are quite complicated to get right. In the past, I have used a local engineering works who could handle this, but they've since closed down, so I'm going to have to learn to do this in-house. So wish me luck. It's tough to know how the steering is going to feel when the car is in the shop, so before I pull the box out, I want to feel out the steering with the linkage connected, and without. Maybe that rough feeling is in the ball joints. With the center drag link removed, I can feel that the ball joints on either side are smooth and moving freely. Whatever is wrong has to be in the steering box itself. It doesn't feel heavy, however, I'm sure that under load it feels much worse. There is a slight feeling of roughness that I can imagine is amplified and can be felt through the Bakelite steering wheel. And I bet that when the car is actually on the road, this roughness is very noticeable. Removing a steering wheel from an Alfa 105 is often a tough job. Breaking the taper fit between the wheel hub and the column itself can be pretty tricky. I don't like to put a puller on these, as it's very easy to chip the wheel, so I use a little tool I made myself. It's just a circular plate that bolts up to the inside of the steering wheel, and in the process puts pressure on the column, forcing the wheel and column apart. And after doing a little disassembling under the dashboard, the whole steering box can be removed. So here we have it, the cause of all my troubles. These boxes usually do three things after a while. They leak oil out of the bottom seal, the end of the worm gear usually wears and becomes pitted, and the aluminium housing cracks. So let's get it apart and see how many of those faults we have here. Unfortunately, it has been packed with grease, which is a common mistake people make with these. I don't care how many people on the Alfa bulletin board say it's fine, or how many mechanics recommend it. It's not a solution. Filling the box with grease will prevent it from leaking oil because there is no oil in it, and it won't provide proper lubrication. And I will fight anyone who says otherwise. I will die on this particular hill. This grease is fresh, however, over time it will go hard, and it will be cleared from the contact surfaces, and there will be metal on metal contact, and lots of damage will ensue. This is me at my most conservative. This bottom arm is seized on really tight, and unfortunately I've disassembled my press. Eventually I gave in and took this over to a friend's house and removed the arm in a hydraulic press. Now let's have a look at the condition of all the parts. So that worm gear, it's pitted up on the end. And this is most likely the cause of the roughness. This surface is where the ball bearings run, and each ball will be rolling over that pitted and rough surface. I imagine that in a corner, at speed, this will feel like the steering box is full of sand. Luckily, the bearing face on the rear of the gear is in great shape, and so are the bearing races. The aluminium case is cracked in 4 places. I think this could have burst open if not repaired soon. It's very common that over time, and especially with wider modern tyres and poorer wheel alignment, like too much caster angle, these boxes crack around the bolt holes where the bearing races are held in place. This will eventually result in total failure of the steering box. I'm removing this O-ring and its retainer so I can replace it with a proper oil seal. That should give this box a fighting chance of keeping its oil level up. The factory changed the seals around 1970, I believe. I'm going to grind out the cracks on both the outside and inside of this casing, and then take it to a specialist welder to have it repaired. I'll save you the horror of listening to a dentist drill and skip to the final product. Now, I know that these aluminium cases just aren't that strong from the factory, and are prone to cracking like this. It's part of the nature of cast aluminium. There are CNC aircraft grade replacements available on the market, for the low price of €1,000, or if wishes were horses. So repair will be the only way forward for me on this job. The welding works filled in all the cracks and resurfaced the gasket faces. More on this later. But they left the bearing surfaces for me to clean up at my request. The welding will distort the shape of these holes, that's unavoidable, and of course the remnant of the weld needs to be cleaned up too. I'm going back to that dentist drill and a file and some sandpaper. I need the bearings to fit, but not to be too loose. I don't want these bearings rattling in the casing once it's assembled. These outer bearing races just fit now. I think they should be fine. I've left the weld bead on the inside of the box and around the weaker spots where the cracks were. I think that this should last a good long while. Part of what causes cracking in the steering box is flex in the chassis of the car. It's a common mod to reinforce the car around the front suspension and stop this, but this isn't my car to modify. I'm sure this car will have a few decades of use before these problems return, and ultimately they will return. This is when you have to apply some zen and the art of Alfa Romeo maintenance. Nothing's ever perfect, nothing's ever finished, and nothing lasts forever. Now, moving on to the internal components. This main vertical shaft is in great shape. I'm just going to give it a clean up and a polish with some waterpaper. The area where the new seal is going to run needs to be nice and smooth if it's going to hold oil. Overall, this part didn't need any real work. I can't say the same for the steering column, unfortunately. I'm going to clean up the top end where the steering wheel fits. Getting this clean and smooth should help prevent the steering wheel seizing onto the column in the future. And now, onto the main event. This is the trickiest part of the whole job, cleaning up that pitted bearing surface on the worm gear. Now, this gear is made from hardened steel, real hard. It's tough to machine. I've been told by people who've been machinists for longer than I've been alive that I shouldn't try and resurface this, that the risk is just too high, that I could break a tool and take a massive chip out of the gear. But I must do it anyway, because what other options are there? There's no such thing as an Alfa 105 parts car these days, now is there? This is a carbide tool that's been ground to the exact radius of the bearing surface. The plan of action here is to grind through that pitting until there is a clean surface in the original shape. It sounds easy enough in theory, so how hard could it be? Turns out, very hard. Even with a carbide tool, it was incredibly difficult to get a cut on this gear. It took metal off at an incredibly slow pace, which I suppose is better than having something break. But after about 4 hours of work, the end of the gear was good and smooth and ready for another couple decades of work. I've cleaned up the casing with some glass bead blasting and repainted the column shroud and steel covers, and the lower arm. I had an abortive attempt with some direct-to-metal heavy-duty paint. I couldn't get a good finish, so I eventually settled on some more conventional matte finish spray paint. Now everything is ready to go back together. I've cleaned and repaired everything as best I can. Now it's time to see if it works. First up, I'm going to fit a modern oil seal into the bottom of the casing, replacing the original O-ring. This is a 28 by 35 by 4mm seal. In the future, I think I will have the casing modified to take a 28 by 38 by 7mm seal, as these current ones are very tiny and delicate, but it should work a lot better than the O-ring did. The ball bearings are quite tricky to assemble. I'm using some low melting point grease to hold them together until they're assembled. Loading up all these parts is pretty fiddly and messy work. These balls are 7.14mm hardened steel. I have a few left over because I bought some new ones. When I pulled this box apart, there actually weren't enough ball bearings in the box to make a complete set. This box had apparently been done by someone else fairly recently. Let's just say it was a few sandwiches short of a picnic and leave it at that. Getting all these components into the casing is going to be a bit of a fiddle. Once the main vertical shaft and the gear are installed, it's time for the outer bearing races and ball bearings. This was a real pain as I kept bumping things and letting the balls fall out into the casing. Maybe doing the rear bearing first was a mistake, or maybe I should have had this whole thing mounted upright in a vise. I don't know, but in the end it all worked out. This plastic ring is part of the top column bearing. There's also a roller bearing in the column that I've added some oil to. It's not worth removing it unless it's in really bad shape because it's almost impossible to refit. I've sealed this rear opening with some gasket sealer and a paper gasket. There are no shims on this side of the gear. I'm going to stick all the shims on the front end. Here are the shims. I'm not adding any sealant yet. I need to test out the preload before I set everything for good. So I think with the shims on this box, because, well, there's two ways to shim this. You shim it sort of front to back and then sort of top down. And the shims that are on behind this plate sort of set the pressure on the ball bearings that are sort of pushing on the worm gear, because it has that bearing face in the back and a bearing face in the front. And you shim it up and get a good amount of pressure on those bearings because they need a certain amount of preload. If it's too loose, what you're going to feel is like this is going to feel very loose, but it's also going to jump back and forth. You'll be able to like push the shaft back and forth, and you'll feel it sort of clicking if it's doesn't have enough preload on it. And then of course you have, if it's too tight, you're going to feel like it's binding up, like you're going to have a lot of pressure being put into the case, especially around the bearings. The other shim pack is the vertical shim pack, which sort of pushes this main arm into the worm gear. And if that is too loose, what you'll feel is, especially at your dead ahead position, because you won't have very good contact between your worm gear and that main vertical shaft, what you'll have is it'll sort of click back and forth where you have sort of play between the two components. And I can't feel anything. It feels like if I put like the tiniest, 1 degree of rotation into this wheel, I can feel it coming out the bottom arm here. So that's probably good. And if it's too tight, if there aren't enough shims in here, it's going to feel like it's binding up, like the two things are being sort of rammed together, and you'll have like real terrible. And this whole thing feels really smooth and progressive, and it feels how it should. And I haven't changed any of these shims. I just put all the shims that were on here back on. And the reason I think it's worked out that way is because when that welding workshop did the case, they took a little bit off the front and the back here. So that's kind of like taking a shim out. But I took a little bit of metal off the worm gear. So that's kind of like putting a shim in. It took a little bit of space. So I think between like the metal that was taken off the case and then the metal that was taken off the gear, it worked out to be about the same. So I didn't really have to play with the shims at all. And these top shims, even though they took a little bit off here, I think maybe there's just a little bit of wear on those parts. So whatever they took off here, it kind of complemented that. So I'm happy with this. So I'm just going to remove this front plate and put some sealant and stuff in here, make it oil tight, and then I'm going to fill it with oil and see if it holds. After letting that sealant dry for a couple of hours, I'm adding some 80 to 90 weight gear oil to the casing to see if it holds. I left it upright overnight, and thankfully it was totally dry the next morning. And with that, the leaks, the cracks, and the worn components are all fixed. I'm very happy with how this turned out, but obviously the result will be how the car drives, so I'll let you know how that goes. I didn't set off to make such a long video about such a niche topic, but I think it's going to be a good resource to have here on YouTube. For years, it seems the go-to resource has been gprocket's thread on the Alfa bulletin board, which I have put a link to in the description. That was a huge help in this repair process, so thanks to the guys in AlfaBB for that thread. Now that this is done, I can get around to putting that engine back in and getting the car back on the road. There are just a couple things left to do on this project. And thanks for watching. Come back next week for the engine and gearbox install. Before I go, I just want to say a big thank you to everyone who supports the channel over on Patreon. It really is a big help for smaller YouTube channels. And I want to say welcome to the new patrons. Raphael Ingelke, Roy and Yvette Cope, Billy, Stain Froelich, Sean Perhat, and Fabio Vassallo. Thanks for watching, guys, and I'll see you all in the next one.